So good morning. My name's Chris Hewitt and I'm from Wild Mouse, although I didn't put it on the slide. And what we're going to be talking about today is perceptual intelligence, or the Perceptual Intelligence APIs from Project Oxford. So first, what's the problem that we're trying to address? The problem is that people can look at each other. You can tell if someone's upset. You can hear things in people's voices. You can see that people have arrived or that they've left. You can hear them and understand what they're saying. They can write something down on a piece of paper and you can read it. You know whether somebody you're communicating with is happy or sad. So these are all things that are quite easy for us to do and actually difficult for machines to do. I guess it's not that surprising that machines have trouble with that. Now, people, if you're dealing with large numbers of customers or tweets or emails or phone calls, you can't have, well, you can have people handling them all, but it's expensive and maybe they won't all do it the same way. So the other thing that we can do by automating these things is to make our processes the same, the experience of our organisation similar for everybody. Okay. In fact, it should be different depending on who the person is and whether they're upset or not, or something like that. So that's the problem that we're trying to address. So what I'm going to talk about, addressing that problem is it's a huge area. So we're not going to talk about building applications that completely automate the internal and external communications of your organisation with people outside. But we're going to talk about the little highlighted bit there, perceptual intelligence, which is part of the whole Cortana analytics suite. So all these things fit together and they drive things that happen to actions that our systems take at the other end. And we're just going to talk about the little bit of it. It's a small but growing piece of it that deals with understanding and communicating with people. As of Thursday, because two of these only arrived on Thursday, which is quite amusing for me. As of Thursday, the perceptual APIs are these 7. And we're going to go through, what we're going to do in this talk is I'm going to very mechanically go through each one, show you what sort of things it does. Each of them is actually quite narrow in scope. And what they are is they're features for you to add, either completely ignore them or go, oh, that's quite useful. I'll add that particular feature to my application. And they all work. Some of them are slightly more complicated, but effectively they're all backed by Azure ML models. So there's various kind of machine intelligences behind all these things, and they all work online, which is, if you want to build an application that's going to run while you're out of contact. When are we out of contact anymore? The reason is that basically all the interfaces to these things are just HTTP posts and things like that. So they're all HTTP interfaces, and that means that they're going to work from anywhere to anywhere. And they're not limited. You can use these things from Windows, or you can use them from Android, or you can use them from iOS. It doesn't really matter. Anywhere that you can make a HTTP call, you can use these features. And so that's what they're there for. I guess the other thing I could say is that it's about 6 months, maybe, since the first one turned up. And a new icon is going to appear on the slide every month, or maybe even faster, because actually people have found some of these things to be useful for some specific applications they have. And so I'd say that this is on the way to being a quiet but major success. And quiet because they're not huge, ground-shaking, the world has changed now, but it just makes things easier for people building apps, and people are using them to build apps, which is what was wanted, I guess. So I'll start off with the Vision API. The Vision API, it does three things. It allows you to analyze images in some detail. So to get from a raw image, it allows you to get quite a lot of metadata. So you don't need to have tags or anything on the image. It just looks at the picture and goes, oh, that's a mountain scene. Is that what it says up there? Something like that, yeah. Outdoor mountain, yep. So it can categorize the image. It can tell you anything it can figure out about the image. And actually, the number of attributes that it will tell you about the image will grow. So not only are new APIs being added all the time, but the existing APIs are getting smarter because basically they're AIs and they're getting more training and they're getting better at doing whatever it is they do. And they're getting more features added to them. So there's other things that they're finding out. So Vision API can, you just give it an image and it gives you back, hey, this is what I reckon about this image. I think it's outdoors in the mountains. I think that the primary color is this. I can't see any people in it. There might be a chipmunk in there somewhere. That's actually the closest the closest kind of outdoor area to Seattle, actually. And then the next thing it does is if you've got text in your image, it will give you the text. It'll OCR it for you, and it does some smart thumbnail generation, which is useful if you're building an image library or something, which is what the next slide is about. So let's go. Things you can do with it. So if you have an application where users can upload content, images, if they can upload images, you can use this to auto-check it, say for pornography, or you might say that this is an under 13 site, so we don't want anything that's more than such and such an amount racy. It's interesting that the AI has got a rating, so you give it an image and it'll say how racy that image is. So I don't know whether that may become our accepted norm, right? Yeah, that one's really racy. Right? Another example, you could use it, say car sales. I mean, who's used car sales lately? I have, right? When you upload your ad to car sales, it takes 2 hours before it goes online because a human has to go over it and make sure that there's nothing dodgy in the pictures or that the text actually doesn't say rude things. And so you wait. For a start, they have to employ people to check, individual humans to check all these things. Whether they do it all the same way or not, I don't know, hopefully, but maybe not. And the customer has to wait 2 hours before their ad is actually posted because there's a time on that. So they could probably automate that to a certain extent. So that what they could do is they could automate it and then just send the outliers to humans for more checking. And the kind of things you could do is work out whether there are number plates in an image, because actually you're supposed to always have a number plate in the image set that you upload, and whether there's phone numbers, which they don't want because they don't want people calling numbers that are in the images. So they'll reject an image that has a phone number in it. So that's just one application. Anybody who's doing applications where images are uploaded could use this, and we're going to see it's fast and it's also cheap. You have to pay every time you upload an image, but it's like 0.0001. Compared to the price of writing code, it's cheap. Unless you're incredibly successful, in which case you don't care anymore, right? If I have 1 billion users, then it's like probably more expensive than writing the code myself, but I don't care because I've got 1 billion users. The other thing is that if you're building an application that handles image collections, or part of your application is about my holiday photos on some booking site for your customers, you can use this to do some things. And I am going to do a demo of that. But to do that, I'm going to switch machines. Does it work? It would work if my machine wasn't asleep. Okay, the place where you get all this stuff is, it's called Project Oxford. So the address is, we can just type Project Oxford into your favorite search engine. It's projectoxford.ai. And these are the software development kits. So I'm going to be doing demos partially with the sort of canned web demos, and partially I'm going to show some code from these SDKs. Really, the code is so simple that it's hardly worth commenting. It's usually 4 lines of code to do anything, because it's just a HTTP post normally and get back some JSON, and then you've got to do stuff with it, but it's very easy to use. And we're going to do the demo. So feature analysis, this is just the web interface for the Vision API. So we can just upload, should I upload that? No, I'll upload something different, okay. Sadly, it can't work out, this is at Phillip Island. Sadly, it can't work out where this is yet. I mean, no, it hasn't got enough information, because there's no tags or anything on there. So, but it works out that this is a car. That's probably pretty obvious. It also works out it's a car if you have some sort of fairly obscure photos. It's like I don't need to take a photo of the whole car. I can take a photo of half a car, and the classifier will go, yeah, I reckon that looks like a wheel to me, and that bit, yeah, so I think this is a car. It won't be as certain. In this case, it's pretty certain it's a car, I'm sure. How certain are you that this is a car? It's not telling me. Oh, yeah, it's there, right, score. It's 98.8% certain this is a car. So, but you could upload some less obvious pictures, and it would be, 63% certain it was a car. So that's feature analysis. You can go into like all of the stuff about what it can analyze, and what else are we going to do? We're going to do OCR, which should be down here. Optical character recognition. So if I load up an image, this is in beta at the moment. So the OCR is getting better every day. This kind of thing that I'm thinking about for this is it may be handwritten things that children do in schools or whatever. You could just scan them. Oh yeah, okay, yeah. The obvious example is receipts, right? All you have to do is take a photo of your receipt, or have an application that takes a photo of your receipt and then sends it up to this thing, which OCRs it and sends you back text, or puts it into your accounting system or something like that. So that's a kind of, it's just a small feature. I think that there's just a single method in that API. Yeah, here's a picture, give me back the text, and it gives back some reasonably complex stuff. Actually, we can see what it gives back. It tells you where it found, it gives you the text, and it tells you where it found it in the image. So that's what your application will actually get back. So useful if you need to do that sort of thing. And the thumbnail one is really for image collections, or any time when you want to make thumbnails. So let's upload something that's slightly difficult. Cute picture. Right. Is that a boy or a girl? The Face API thinks it's a girl, age 5. Yeah, it's not. It'll change. It's not actually that good at very young people. Yeah. So this is which one? Oh, smart cropping is on. I should have started with it off. So when you crop this image, what the artificial intelligence part of it, I mean, it's easy to make thumbnails of images, right? We can just subsample it down. But what it's doing is it's working out what the important features of it thinks the image are, and trying to keep them in the center. So the thumbnails, actually, that's smart cropping off. So with smart cropping on, we should see more of his face. Yeah, see, so where it can, it's bringing the important features into the thumbnail. Not hugely earth-shattering, but if you want to make thumbnails, it's a really good way of making thumbnails. Okay, did I have code for that? No, I tried to, the sample code for that is a console app, so we'll flip back to number 5. Okay. Okay, so the next set of APIs we're going to look at is the Face APIs. And they're actually, there's a lot more work gone into this than the Vision stuff. Actually, it probably uses some of the models from Vision. and then adds face to them. So what Face API lets you do is detect faces, verify that two faces are the same. And the next slide is about what you can do with that. But a classic example of that is that if someone's going in to sit an exam, a student is going to sit an exam, you can just scan their face on the way in and match them up against the face in the student database. So you know that person sitting this exam is that person without needing a proctor to kind of look at an ID or something. Similar face searching really is for collections of image collections. So you can say, oh, that's so you get, here's 1,000 pictures from the company barbecue where Bruce was really drunk or something. Here's Bruce. Show me all the pictures of Bruce being drunk, and it'll go through those 1,000 images and find the ones that have Bruce in it. So that's the similar face searching. And grouping again, let's, out of all these images, make me a group of all the images with Sally in them. And identification is really for an idea that somebody had yesterday. Who was at my talk yesterday? Anybody? Sort of slightly similar ground. Different. It's a different talk. They had the idea of when children come into school in the morning, you just have a camera set up. These things can handle up to 64 faces in an image. You just have cameras on the way into the school, and you'll see the children entering and leaving, things like that. And apparently that's okay. It's a bit, and that's a good point. When you go and have a look at the rules, what you have to agree to when you use this is that you're not going to do anything evil. So there's quite a lot of do not do evil stuff around this. I'm using these images, and those are images that I've purchased from people who are getting paid. Those two people are getting paid to sit there and at a movie, and one of them happy, one of them sad. So these are all, I'm not using random images from people that haven't agreed to have their images used like this, which you shouldn't really do. But apparently school children don't have a choice because it makes it easier for the teachers, right, if the roll call is just automatically done. And that was one of them. So there's thousands of uses for the Face API. So howold.net, I don't know who's used that. I have. Howold.net is powered by Face API. We could use it to, the current kiosks at the airports, when you're coming through customs, are pretty slow. You don't need to stand there for a second. It's just like, there can be a stream of photos going to something which is going, that's Chris. I remember him from last time, right? You can just walk straight through customs unless somebody taps you on the shoulder. When we get to emotion, we might talk more about why somebody might tap you on the shoulder, but that's for later. This is being used for face recognition login, so it's good enough. If you have if you're highly confident that this is the person, you can actually use it for authentication. There's a find your clones feature. I think this is the same guy 3 times, but I'm not sure. Just an image I found. You can use this you can get features out of the face. So Face API gives you a whole lot of information about each face, and you can use that to feed it into other AIs that do something else that you invent. So it's another example I thought of that if you're a bar, you could just have, if you've got pictures of people that aren't allowed in the bar, you can just have a camera set up at the entrance, and a little red light goes off for security when somebody who's on the excluded list walks up. Right? You don't need to have a little bit of paper with everybody's faces on them or check their IDs or whatever. You can tell. Oh, and actually, there's a good point. So you don't need to check IDs for people whose IDs you've already seen. So you know how everybody has to show their ID. It's just that if you've been there before, you could just walk straight in, right? And the little thing will go green, green, green. And if it hasn't seen your ID, if it hasn't checked your ID, it'll go red, and security will say, can I see your ID? So you can build that kind of application with this. Who's going ding ding there, I wonder? All right, so we're going to demonstrate Face API. There will be code now. Well, small amounts of code, small non-scary amounts of code. Yeah, let's do it in the web app. Oh, no, we don't want that. That's not our browser, is it? So let's upload those movie people. So yeah, those are the two people in the movie, and you can see that we actually know quite a lot about them. The API returns all this information, so where their eyebrows are and things, which is useful for other stuff. But it also tells you how old it thinks, what is it, male or female? How old is this person? What way is their head facing? Things like that. That's kind of cool. And verification we're going to do in that. Yeah, just did it then. There are a lot of computers behind this. I mean, most of the time was spent uploading the image. No, actually, there's a good point here. If somebody wants to use it, the images don't have to be that detailed. So in order to make this demo work quickly, I downsampled all these images. Really, for, say, a picture like this with a couple of faces in it, 250 by 250 pixels will be fine. Right? That'll be enough information. It doesn't need huge amounts of information. So you can downsample and then upload. Yeah?
With the Face ID,
yeah.
if you would upload like a subsequent photo,
yes.
does Microsoft remember that same ID?
Yeah, it does. Yeah. So
well,
yes. Basically, the answer is yes. It's a bit complicated. You get a GUID back. You have a subscription ID. I think the GUIDs are always unique, right? But yeah, that face is related to your subscription ID. So yeah. So as far as you're concerned, other people won't get that information, even though the machine might have it. Yeah, and it's already got millions of images, but it's not going to be evil, right?
Sorry, one more.
Yeah.
Would that Face ID in the background though be shared across subscriptions?
Probably not. Actually, the truth is I don't know, but I suspect not. I think it's, and actually they change sometimes because later on we're going to see, actually in a few seconds, we're going to see where we're doing people collection. So there's actually there's an entity model behind this, and it's like faces, people, groups, things like that. Sometimes the groups get confused and you have to regenerate them. So it says, I've lost track. Could you upload all the pictures that were in that group again, and I'll give you another GUID. So yeah, I don't know why that happens, but it does sometimes. So yeah, I assume that the GUID will be different. Let's go to the code. So that's Face API. Only if it's got something to be trained on. So I think it's more complex than just a single model as well. I think that the accuracy won't go up by just what we upload out of our applications, but they will do more training because they have to like that thing about the age. Those are actually well, I guess we should say that. Those are the perceived ages. So they're not like, they haven't uploaded 1 million photos and with the actual birth dates of the people in the photos. What they've done is they've got 1 million photos and then they've got people somewhere who look at the photos and go, yeah, I think that person's around 45 or, so there's actually probably a lot of humans who did the original training data for the how old thing. And it's just what age they perceive them. And they need to make that better, that age perception better. Like we said, it doesn't do very good with like babies. You give it a baby photo and it says 22 or something. So, because they haven't trained it on a whole lot of baby photos. So probably even as we speak, there's someone somewhere going through baby photos going, I think it's about 3. 2 months, that one, yeah.
So that means that the training model in the back end potentially could get better, so you could resend all your pictures 2 months.
Yeah, that's actually something, you have spotted something that I was going to slightly skirt around, and that is that the underlying AI is going to change over time. And that means that if we build an application and we have test data or something, so we have test cases, we build an application with test cases and we run it. 6 months later or 3 months later or a month later, when we run the same test cases, we might get slightly different results because its confidence about whether this is a car might go up or down or something because they're going to get better. So that's a bit of a pain for programmers, but as a person using the service, I think I like it getting better. Yeah, so I'll put up with the pain. All right, so what are we doing? We're doing code, right? When we're not really doing code. I'm going to keep what we would. It happens every time, doesn't it? Maybe we're not doing code. Yeah, yes, we are. Yeah. Basically, I should have showed that is the call, right? It's just to set up a request and do send request async to an address. It's that easy, right? So detection, we'll do coupling. I've showed you this, really. It's exactly the same thing, but instead of their web application doing it, it's our WPF code. Verification. Yeah, okay, we didn't really do that before. So let's say happy Bruce and sad Bruce. Yeah, so we're pretty sure that that these are both pictures of Bruce. I'm surprised that the confidence is only 0.7, but I guess that can change later on. Okay, so we can group photos. Hopefully there should be, yes, I've got some sample images that I can group. And so what it's done is for these 12 images that I've sent in, it's looked at them all. Actually, it's looked at the faces. The images were bigger than that. It's found the faces in the images, and then it's grouped them into people groups that it thinks. So it's identified, it will have GUIDs for each of these people now. Right, so it'll go, yeah, that's Annabelle or whatever. It doesn't know their names, but it knows them by, it doesn't know their names, but it knows who they are. Okay. Find similar. So this is that thing I was talking about. Again, I've got a general thing of people. I've got to watch this because I'm rate limited. I'm just using the free. The service is free as long as you don't use it too much. It's all right, 8 faces. And it's sort of too much within a minute. So I could get, so this is the candidate faces, and so that's my collection of images, and we'll try and find sad Dave. Okay. And sorry? They're all beta, but they will sell it to you. So they're all in beta, and they'll probably be in beta for a year. But if you have a credit card, they will not rate limit you, and it does work. So yes, it's beta, but yes, it also works.
Yes,
so.
Candidates, are they basically stored against your subscription, so you don't have to log them every time you do it?
They can be, yes, they can be.
Yep.
Exactly, yeah. So because I'm doing this over and over again, I'm probably getting a new GUID every time I run this demo. So I've probably got a bazillion images up there because I'm not using it properly. But the documentation in the SDK is pretty good, and they're very helpful. So this one is this is actually one that I'm kind of quite interested in figuring out how to do things about. So I'm going to load a collection of people. And in this case, it knows these people's names because those are the folder names. So that's the way that works, or this particular piece of code. What are you doing? Okay, so it's trained on these groups of people. So let's go Happy Dave again. So now, if I upload this picture, so basically that's my, I load the first lot up. I load all my students up beforehand and store them against my subscription. And then when Happy Dave comes in to do his exam, I take his photo and I pass it up to, I actually probably downsample it. And also, there's no point in sending color because I think part of the process is it grayscales it anyway. So maybe on my end, I take his photo, I grayscale, I downsample it, I grayscale it, and then I pass it up. And it goes, yeah, I'm some percentage sure, which would be down there, that this is actually Dave. So yeah, actually very useful piece of kit. Let's go back to, how am I going? I should either speak faster. We've got half an hour, and we've done 2 out of 7. I should speak faster. Or maybe I should stop going on. So the emotion API, it analyzes facial emotions. And I have used, because this is an area that I've actually been working in for various reasons, I have used several other services that do this for you, and I understand something about the underlying theories behind it. And it only came out on Thursday, so I haven't had a lot of experience with it, but from what I can see, it's actually better than all of these things that have raised millions of dollars, and it detects people's emotions from their facial pictures. And the kind of things that we could use that for are, so if you're doing distance education, the webcam on the student's machine can see if they're happy with this, or so you can get feedback from people who are remote, or I guess people on the other end of a big Skype conference call. Hey, Bruce is looking a bit tired or something. Tired is not one of the emotions it actually detects. By the way, those emotions are Ekman's universal emotions, and they're theorized and argued about to be the 7 emotions that that are cross-cultural, that every human exhibits in a similar way. There are many, many more emotions, obviously, and there are actually many, many more emotions where we have theories about how you would detect them, but those are kind of the ones that most people think work. So who's seen, it's Inside Out, right? Yeah. They're the little characters from Inside Out, and we can identify them from photos. And somebody's already done howhappy.net. Damn, it could have been a contender. I actually thought about it, I actually thought about it, but it'd be really easy to do, but if it's actually successful, I don't really want to pay for all of the Azure usage that would generate. Gaining, I could have a camera here. I don't, it's all right. I could have a camera here, which would be telling me, how happy the audience was or whatever on a little meter. The border security one, I was thinking of a really stonking big camera, like one of those things with the big red eyes, like in the science fiction things, big scary red camera and lots of signs saying, an AI is just about to have a bit of a quick look at you. And then what you do is you detect fear, and you go, when you see somebody who's afraid, you go, okay, I think we might have a word with you. So yeah, I imagine that you want to be a bit more sophisticated and subtle than that, but that's the kind of thing that you'd think of. All right. I'll try and make this demo real quick. Open 6. Yeah, we've done you. What was I going to do for emotion? Oh yeah, okay. Actually, that's a good demo. So here's some code that we're not going to run. Basically, those 4 lines in there are what does it. That's all I have to do. I get an HTTP client. I create a emotion service client, and that's from the SDK that you can download from that web page we looked at before. And the only command in the API is recognize async. It has 4 different parameter sets. So it's either a stream or a URL, and then there's a couple of options on that, but that's pretty much it. And then you just wait, and you get back a list of the emotions, actually a list of the faces and emotions that were found there. This API uses Face API. So it calls Face API just to get the face rectangles, and then it analyzes the emotions in the face rectangles. So that's an example of how these ML models can kind of work together to build bigger and bigger applications. All right, so what we're going to do is look at the results of that. So when I pass, that piece of code there, what it does, it actually passes a batch of images to the Emotion API gets back the results and creates a spreadsheet, which is this spreadsheet. So this is the output from that application. It actually found 2 faces in the first one, and it's saying that he's happy and she's sad. I think we can all agree that it's done a reasonable job of that one. And let's go down a couple. We're not going to go through all of these. So this, the only thing to note about this is that these are actors, and they were asked to. That lady should get an award for her sadness, because they asked people to look happy and look sad. No one can act sad, or it seems to be really hard for people to act sad. They all look neutral, and it's not just Emotion API. It's not Emotion API that's doing this wrong. I've passed these pictures through several different emotion detecting APIs, and they all say the same thing. They're not sad, right? Yeah. So people can't act sad. There's a good takeaway. I mean, you can be sad, and you're going to look sad when you're actually sad, but you can't kind of make out you're sad. We don't know how to do it. Right. That'll do. It just works. It's really very simple, and it just works. The speech API, right, I've got to do something special for this one, and it's got to do with,
The icon says it all. Text to speech and speech to text.
which is, it's just a post, right? So all you do is you do a post, and the post includes, in fact, that's it. That's the code you need to put on your web page, and your web page can speak. So I guess the underlying theme of this is that there's a lot of really complicated things happening in the background, but it's really easy to do. Okay. No, I need to go here. I mean, it's pretty obvious what you're going to use this for. You can put speech recognitions into your applications, and you can get your application to speak. Now, there's another thing we're going to look at, the Language Understanding API, and that lets you take natural language and turn it into basically into, well, they say intents, but actions and entities. So if you're building an MVC app, right, Lewis makes things that match your, you might have a different Lewis app for each controller, maybe not actually, maybe you have it for your whole app, but it maps to actions on your controllers and entities in your models. So it takes natural language, which can be spoken. So you use the speech API to take their speech and turn it into words, and then you take the words and you give it to Lewis, and Lewis turns those into actions and entities that your application can then act on. So that's how you add voice control to your application. You know, we don't necessarily want keyboards anymore, so we can get rid of the keyboards and make our applications voice controlled, and it's a simple add-in. Well, it's 2 actually, so you need to use 2 of these APIs to achieve that. Okay, at the moment, I think speech API is 2, so it's English and Chinese, and they're doing Spanish really, really quickly, so like next week or next month, Spanish, and they're aiming to support, you know, all of them, right? So they're putting a lot of effort into training it. I mean, effectively, the model is probably the same. It just has to be trained differently, and actually, they have to detect which language it is. So you don't even tell it what language it is. It works it out. It's not English or it's Chinese. So. Yeah, sorry, I should be saying that the reason that they're doing these things is because they have to do them for Bing and Cortana. So a lot of these features are actually used by Bing and Cortana, and they're going, well, we have to build this anyway. Why don't we also make some money by selling it to people? So yeah, it is the same code, right? And that means that it will get better, and you know, blah, blah, blah. Why can't they recognize Australian? They can't recognize Australian. I have to go English GB, so I don't know exactly where they are on that continuum. But the general idea is, yes, there is only one speech recognizer, and this is the Cortana Analytics speech recognizer that we're looking at here. Okay. 12:10. We'll be fine. What was I going to do for speech? Okay, Show demo in web. All right, good. Got my, I keep clicking on that nasty icon down there. I need to click on this nice icon. So speech to text, it can recognize me with English. Actually, so here, sorry, I was completely wrong. Chinese, English, French, German, Italian, and Spanish. Duh. Right. It works for me with US if I kind of put an accent on, but I'm better off with English GB. So it can understand me speaking. The it didn't quite work. The other thing is it's using WebSockets. Oh, it keeps going, as long as I'm close to my microphone. It's using web. You see how it's updating? It's because there's actually WebSockets behind this, and it is basically it's sending a stream, and as the stream is analysed, we're getting events coming back saying, oh, I think this. And you notice that sometimes it changed its mind. So its first guess was he's saying, time or something like that, and it goes, the next thing that comes back changes it. So yeah, that's actually very good. Using WebSockets, good. And the other one, really, we already heard. But we do it again just for fun.
I can understand speaking. It didn't quite work. Using WebSockets.
Okay. We've only got, most of them have got a male and female voice at the moment. We've only got Catherine, but I guess there's also more of these coming as well. What else do I need to show? I think I might skip the app. We'll have a look at yeah, I've got the app here. We'll just have a quick look at it. It would have been a much better demonstration if I got the Lewis stuff working, but it didn't seem to sync with my Lewis application, and I don't know why. But yeah, well, this works as well. So this works as well. That's big. You can see actually, that does show you something interesting. It doesn't just, in that web API, because it's a demo web API, it just showed you, what its best pick for what the person was saying. But what you actually get back from the API is you get a set of things that it might have been, so that your code can pick the one of those that you see. It's mostly high. The highest one is so this works well. Actually, what is it? Gotta put my glasses on. So this works well. All right. So it gives you all those options, and your code can sort out which one. If there's some reason why one of them doesn't make sense, you could even pass it to Lewis. And in fact, that's a general idea. You use this to get these things back, and then you take these and you pass them to Lewis, which turns them into commands for your application. Let's move right along. So Lewis is language understanding. I think they just wanted to say Lewis, so they found two useful words and stuck them on the end. Well, that's good. It's memorable. And I've already really said what it does. It detects intents and entities in natural language, and it gets better all the time. And it also, actually, that's quite an important thing. You can reuse. There's a lot of stuff, a lot of work being done in Bing and Cortana about understanding things like time and places and people. And you can add that to your model or leave it out. I actually added places and people to my model, and my model started to go funny, so I took it out again. And that sort of, I've said that all over again. So yeah, you get rid of the keyboard. With Speech API, you can take out the keyboard. So look at Lewis. Ooh, I'm getting too close to that thing. Mostly online, really. So here's one I prepared earlier. This is called Simple 2001. Simple because it doesn't have the encyclopedia in it. So we can, I was hoping to say this and get it to be analysed, but I'm having to type it. So I'm typing, let's imagine that I said, hey, hell, open the pod bay doors today. And I can just hit enter. And that's the response I get from. So remember, all these API calls, they're just posts. So that was just, I did a post and I got a response. And the response I got was, it's pretty sure that I wanted to open something. 97% sure that I mean open something. And the things that it found in this speech were the pod bay doors and hell, and also found a date time of the 18th to the 11th, 2015, because it found today, and that's part of the Cortana library. So yeah, that's how does it work? We've got time to talk about how it works. Yeah, we've got a little bit of time. So what you do is this only knows these three things. So this is how you train it. Now it's about opening doors. Well, let's come up with a different thing for doors. What's a good synonym for door? I could ask some. Gate. Yes. Yeah. Shut the bleeding gate. Hell. Okay. So this is training. Now, the programmer, me, looks at this. So this is the thing that we're going to use to train this AI. What happens is that each application, so what I've done is I've got a subscription. In my subscription, I have multiple applications. Each application has a model. So this is much more specific. I'm working on the Lewis model for this particular application. And it already knows from when it looks at this, this training data I put in, it's already guessing that is going to be the entity hell. So I've defined you can go up there and add intents or entities that are going to be in your application, but we'll stay with those for now. And you can also add, I'll click on that one and add some things. But it's going, yeah, I reckon that's hell, actually. If it wasn't supposed to be hell, I could click on it and say, no, it's not. So if I click there, it will say, no, it's not hell, but I won't. All right, but what I'll do is I'll highlight gate and say that I think that's the pod bay doors. And shut, I'll highlight, actually shut is, no. So the intent of this whole thing is close. Hopefully it's going to, you know what, it hasn't got enough information. So what I'm saying is that the intent of this entire phrase is to close something. And I'm going to submit it and I'm going to train it up on it. But since it's the only thing with shut in it, it's not really going to know whether it was shut or bleeding that caused the close signal. If I gave it a few more sentences like this, then it would work that out. But that's okay. So we can actually try bleeding and see if it says close. There's an error. Okay, it's just that the current trained model has got an error on that one. And so let's see what the error was. The error is going to be that that the current model, when I say shut the bleeding gate hell, it thinks it slightly probably means open. So what I'm going to do then is I will no, I'm not going to. I'm going to use all my I'm going to train it again. It doesn't take long. It's just it hasn't got a lot of data. It's trained. Okay. I have to train it, and then what I was using before, what we were looking at before, was actually so there's a trained model now for this sitting up there somewhere in Texas, and what I'm going to do now is publish it, which is basically making a web service that allows you to. So now there's a web service that has that newly trained model behind it. And if I say, shut the door, now, it's probably, I don't know what it's going to say. Oh yeah, it thinks it's closed. Okay, that's good, excellent. So it thinks that it hasn't really found hell. That's confusing, but never mind. What if we say bleeding door hell? it's probably going to think that that means shut. Yeah, so we just haven't trained it about the difference between shut and bleeding. Okay, that's good.
When you start using this and you're training these models,
Yeah.
is it storing all of that like in a big data store of everyone's?
Somewhere. Yeah.
Is it crowdsourced storing all of that?
It's storing it, and I don't know where they store it, but you could imagine that they're storing it in blob storage in whatever Azure data center this is on. So this is all.
I guess what I'm trying to say is like if you're crowdsourcing everyone doing this,
Oh, you mean like?
context that they're doing it.
No, you're not. Not for this one. In this one, I, the programmer, am defining the language. Yeah, through this interface. I'm actually designing it. So, and I know a little bit. I know that if I want shut to work, I'm going to have to give it a couple of examples or actually, I could have just said shut the door. It's going to ignore shut, it's going to ignore the, and it's going to know that shut means close. So that would have been a better training utterance to give to it, yeah. Okay, well, that's pretty much how it is. We don't really need code for this, do we? Yeah, we've got code. There was some in that other API sample, but it doesn't matter. That's pretty much what Lewis does. And you can go and read the documentation and just download the samples and play with it. It's fun. It's fun and free. In fact, I think it's totally free at the moment. What did I just do? I went to 7 instead of 5. It's a good one. So again, this is the spell checker that's used by, as far as I know, Word and Bing. Is it? I don't know what. No, I don't know. I don't think it's the one Word uses. Maybe. Anyway, it is a spell checker that's used by a bunch of other Microsoft applications, and it does all sorts of crazy, amazing things. And there's only one use for it, which is you can add spelling to your application. I'm not even sure that we need to. Actually, we've got plenty of time. All right. What it does is it takes your text and it spell checks it, and it tells you whether it tells you what the possible spellings are. And then the other thing that it does is there are two ways you can use it. You can use it in proof mode, and proof mode includes the encyclopedia. We didn't show that, did we? I missed something out in Lewis, so let's go back and I'll show you something. I meant to click on this thing. Hello? My clicky thing isn't working anymore. My other clicky thing is working. Oh, no, because I'm in because I'm stupid. All right, so yeah, so these are the things in Lewis that you can use. Like, it knows about numbers, it knows about first, second, third, 15th, it knows about temperatures, it knows about dimensions, it knows about money, age, geography. That's dangerous because it's so huge, but it knows about stuff like, it knows Chris as a name. So the encyclopedia knows Chris as a name, knows about percentages. And the reason that that's important is while we're here, we may as well demo the spell checker. Is that in the spell checker, I've already done it. It's already pre-done. So if I just spell check it, my name is Chris. It'll find the error and correct it. That's when I'm in spell mode. So spell mode is like the spelling behind the search bar in Bing. That's the spell mode. This one is a little bit more like a word processor. And the only difference, there's a subtle difference there, is that it actually has the encyclopedia. It looked at that and went, okay, yeah, the spelling needs to be fixed. And that thing is actually a person's name because I know everybody's names. And so I'm going to capitalize that. So it does more than that, but that's pretty much what a spelling checker does. It's a spelling checker, and it's just sitting there for you to use, and you can use it with 4 lines of code, and it works. And it'll get, if it doesn't work, it'll get better over time.
Is that only available on
Oh, yeah. It was a question that I was actually at the Cortana Analytics workshop in Seattle, and that very question was asked to the Project Oxford team, and their answer was, yes, that's policy. Because, all right, so there's a quid pro quo, right? What you get is you get to use all these actually huge, I mean, you can imagine how much code and how many, they're probably using AIs and stuff behind, how much stuff sits behind a spell checker, a kind of high-end spell checker. You get to use it very cheaply and incredibly easily, but what you pay is that it doesn't work offline. It's all done through HTTP calls. So, yeah. Everything is, your fridge is supposed to be online. So with this, you can allow your fridge to spell. Doesn't make any sense, does it? But yeah, you could do it. Yeah. There's going to be, unless there are specific requirements for something, once they have a model that works, they'll just use the same model everywhere. I mean, they can deploy it 100 times, but they can train it once and deploy it 100 times, or have the model and train it 5 times for 5 slightly different applications and deploy it 100 times. So they have a lot of choice here. But if using an Azure ML model is the right solution, it's not always the right solution, but it seems to have quite a lot of, it's quite a useful hammer. If one of those is good for a particular problem domain, they actually only have to do it once. They can build the model once, and they can train it many different times. Yeah. So hopefully, I think this is the last thing. Not hopefully, I'm aching to get out of here, but I'm hoping that I'm remembering correctly. This is the last topic we're going to talk about. Text analytics, which just does 2 things. It does them really well, and it does them really easily. So again, 4 lines of code, and you can do sentiment analysis and key phrase extraction. So what you use this for, I should have actually said what you use it for. It's more like what it does. What you would use it for is that if you were a site that had lots of reviews of products, or maybe your company has reviews of products, or you collect information, you collect things from places, you can just put it through this, and you can get the sentiment out of every piece of text you put through it. What you can do then is that now you've got these pieces of text with sentiment values, you can also categorize them by the key phrases that it also detects in them, and you can do lots of data analytics on that, and you can go and work out what it is about your product that people like or that they don't like. This doesn't do that, but what it does is it gives you the raw data that you need to do data analysis on lots of user-generated text. And I'm doing this demo because it's fun, right? Some of you have seen this before. All right. So I'm going to do I Love Melbourne. Hooray. Oh, why is it taking so long? And of course, you know what I'm going to do next, right? So 82% for Melbourne. It's changed from yesterday, by the way. So the actual machine is 86% for Sydney. So Sydney rules, okay? And so 86% for Sydney. I think that's changed since yesterday. I can't quite remember. 93% for the Gold Coast. All right. So yeah. And why? Yeah. Okay. So actually, that's interesting because it tells you about the text analytics. It's what it is that on the data that it was trained on, there are lots of words in the phrases that it was trained on, and a lot of this would have been trained on tweets, millions of tweets, because that's an easy thing to get, and actually an easy thing to classify for the training. Because if it's got a little smiley face in it, you probably think, yeah, it's probably a happy one. Also, hotel reviews, which is easy to use for training because people they write stuff about the hotel, the such and so, the sheets were unwashed, so and so, and then they give it a rating, of 1 or something, or 5, and so you can use that to train, as grist for your training mill. And I imagine, I don't know, I'm just guessing, but I guess it's been trained on a lot of these things. And the reason that there are different weightings, because the text is pretty much the same except for the location. There are different weightings on the locations, is that people who stay in the Gold Coast generally write happier hotel reviews than people who stay in Melbourne, etc. I think that's what we're seeing here, the effect of what the training data was. But yeah, you just put any piece of text in it, it will analyze it, it will work out what the key phrases are. And it's quite, again, like everything here, it's actually pretty simple. It's easy to call. If you don't need it, just ignore it. If you do need it, it's probably a lot easier than trying to build your own model to analyze whatever it is that you want to do sentiment analysis on.
So if you wanted to use that technology on confidential data that you want to put online,
Actually, no. I've got the answer to that. You have to put it online, but it can be in your own. It can be in your own model because there's also a thing called the text classification template. So this is the text analytics API, which is just meant to be used by people from all over the place doing posts. The underlying technology of this, there's a template for it. So if you go to the Azure gallery, you'll find a text classification template, and that's basically how to build one of these yourself. You have to build it and train it, right? You could train it you could pay these guys, because you're going to get charged some minor amount for every phrase you put through. What you could do is you could take advantage of the training of this, and you could take, a million pieces of text that you have, put it. No, actually, that's confidential. You don't want to do that. Okay, sorry. I double snookered myself there. Yeah, right. Okay, you have to train it. So you have to provide the training data, but at least you can be sure that it's sitting in your account, it'll still be in Azure, right? It's going to have to run in Azure ML. It'll be sitting in your blob store in Sydney or Melbourne, so you can take it to that level. But yeah, it has to go online. It has to eventually, because Azure ML is all online as well, so it has to go up there. There's no local. Am I allowed to say this? Yeah. No. There are toolkits that you can download that you can run on premise that do similar things. Not as good, and the real advantage of this is just the sheer kind of amount of grunt behind it. So I can just type one thing into here and it works, right? I know that I could, in the next minute, upload 1 million pieces of text to the service and would still continue to give me responses at that rate.
Even if you knew that it was encrypted in some way, there's a very good chance that you isn't set it.
Yeah, but the trouble is the API needs to see the text. Yeah, it's not going to be able to get the sentiment without getting the text out. Yeah. Oh, yeah, there are ways of doing it, but... Okay, that's pretty much, we're close to finished. It's good, because we're all hungry, right? I know I am. Just a couple of examples of things that are built with it. Bing and Cortana, okay? Classic examples. Bing and Cortana use some of those features that we just looked at. There's a tool called Microsoft Content Moderator, which if you are building a large website that has lots of user-generated content, or maybe you're an education department and students can put stuff up somewhere, you can use this. And there's also some other more secure tools that are associated with it that are for looking after children online and things. But starting with Content Moderator is just a product that you add to your online application, and what it does is instead of you having to worry about it or your people having to check it, it will check the content for you. And I think, I'm remembering this, I think it also includes some people who actually look at things that are outliers and stuff. So yeah, that's a useful feature. I'm not sure what this is. I mean, no one, I don't know. A few people have seen it. I've never seen it. A few people have seen it and they go, wow. By the way, there was a point to the previous slide which it uses, Content Moderator uses Vision API, spell check, and some independent machine learning things. GigaJam is using Lewis and the speech to text. So basically, not the central functionality of it, but some bits of it that are voice controlled are done with speech and Lewis, which is, absolutely the right way to do it. GigaJam. Do we care? Yeah, it's kind of vaguely interesting. Let's see. I did that. I clicked that thing again. All right, so GigaJam is some sort of kind of crazy working together tool that integrates everything else in the whole world and Cortana and lets you have to go and have a look at it and watch the videos, and you sit there and anyway, so I haven't actually seen it. I watched a couple of videos. I've seen some people who've seen it talk about it, and they're going, it might work. It's crazy, but it might work. There you go. So let's flip back to that. GigJam, right. And I already showed you the SDK, so it's you can download from here. It's on GitHub, NuGet, and Maven. So yeah, we looked at what is in the Perceptual APIs so far, and that's the summary, is that these are things that just allow you, if you want this kind of thing, to easily put it into your applications as long as you don't mind, or it's always online. Right? But yeah, emotion detection, I don't know that I would have ever been able to do that in any application under any circumstances. And I can already think of a few things I might want to do with it. Yeah, if I get away with it. So yeah, it's good. So yeah, please fill in your evals and win a prize. I haven't actually been to any sessions yet, so I haven't got any chances to win a prize. And I didn't put anything special on here, but remember I told you at the beginning, just type Project Oxford into your favorite search engine, and you'll get access to all these things. Thank you. Yeah.
With the Emotions API,
Yeah.
it works with photos right now. Are you guys going to think of introducing voice emotions?
Okay, that's an excellent question. So the question is there going to be voice emotion recognition? I don't know, but there are such things. So Beyond Verbal has a very interesting voice emotion recognition thing. I strongly suspect that this is being done by Microsoft Research, right? So it's interesting. You notice it's always in English and Chinese. I think there's quite a lot of stuff happening in Beijing about this, right? The lads are probably going to, I have no idea exactly what they're going to do, but I would say that's one of the next 3 or 4 things that's going to appear. So soon, probably, but I don't know. I'm guessing. All right. Anybody else? No? Yeah, sorry, we got one.
So in terms of the image recognition, has there been any development in terms of understanding vegetation for it?
Yeah, that sort of thing. Okay, so the question is, how good is the image recognition at categorizing effectively what's in these images, what the content of the images is? Up until last week, it had 86 categories, and as of now, I'm not sure that it's behind that demo yet. As of now, it's got 1,000 and something categories. So yes, it's getting better at categorizing stuff, and also I think there's the ImageNet challenge, which is basically categorizing images against an encyclopedia. The guys who are doing the basic research for this do very, very well at that ImageNet challenge. So yeah, that online demo at the moment, it didn't detect the vegetation in that cascade. It said, oh, it's outdoor mountain, but it didn't say there are fir tree. I'm sorry, there are whatever kind of trees those are there. But yeah, as far as I know, next week it probably will, right? But it's gone from 86 to 1,000 categories, and yeah, watch the space, yeah.
Chris, is the ImageNet categories, that competition, is that going to be the benchmarkers and the categorization?
It's just that the people who are, so the question is that, oops, I've gone off my slide. The question is ImageNet the aiming point? For these guys it is, because the people that are doing this are not the guys that started at Microsoft after. What they are is basically Microsoft Research, right? And they want to win ImageNet every year. And so yes, the primary focus of their existence is winning. Yeah. Well, we have there's a lot of people at Microsoft Research that want to be number one On ImageNet, yeah. Okay. All right, we're all done?
Can you do Gold Coast is shit and Gold Coast is
Yes, I can. So let's see. Yeah, I think that was something that, as long as the cameras are off, I can do that. Let's turn the microphones and stuff off and just...